Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamburo. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we'll be revising physics, which is paper 1. So that will be our focus. And we are saying the format of your question paper in terms of prelim and final exam, as stated in the exam guideline, is that we have two types of questions that you'll expect. That is your multiple choice questions and what we refer to as structured questions. So multiple choice questions will still be your 20 marks, which is about your 13% of your paper. And then the rest, 130 marks, will come from structured questions. So you are expecting about 9, 10 questions or so. And then in those 10 questions, we are saying structured questions, 130 marks. Multiple choice questions, 20 marks. So it's important that you spend some time doing your multiple choice questions and ensure that you get that those 20 marks. I think it's very much important that you do as well in multiple choice questions. Usually our multiple choice questions are taken from each of the sections that we do. So that is under mechanics, you'll have your Newton's laws, and then you will have your vertical projectile motion, your momentum, your work energy and power, your Doppler effect, your electrostatics, your electricity, your electrodynamics, that is motors and generators, and then lastly your photoelectric effect. So you're expecting at least a multiple choice question from each of those sections that I just indicated. Now, in terms of marks, the exam guideline says mechanics, we have 65 marks from mechanics. Doppler effect or work energy, wave, sound and light, we have 15 marks from wave, sound and light. Electricity and magnetism, we have 55 marks. So you can see it's as important to do electricity and magnetism and do it well. So let our focus not be in one of the two sections. Both mechanics and electricity and magnetism must be given a right attention in order for you to be able to get all these marks. And then lastly, we have metal materials. In this case, metal materials, we are referring to our photoelectric effect. Now you will check in this term, in term 3, you have done electrodynamics, your motors and generators. I think they are still fresh with yourselves. And then you have done your photoelectric effect. You will definitely tap into them. It's always good when you are revising to start by revising these topics that you were doing just now, so that you capture everything and you get all of those marks. So I think when you are still fresh, ensure that electrodynamics, photoelectric effect, you spend some time doing those topics. You do them, you put them aside, then you focus on your term 1 and term 2 topics, because there will be a lot of marks as well that will come. Remember, mechanics, you have done it in term 1. In term 2, you have done work, energy and power under mechanics. So you can see it's mostly term 1 and term 2, your Doppler effect in term 2 as well. Then term 3, you were able to do your electricity with the focus on internal resistance. Remember now, internal resistance is part of our syllabus now in grade 12. So it's important that as you prepare, you always balance yourself. Don't just do only term 3 topics that you still remember. Please spend more time with your term 1 and term 2 topics, which is the focus of this lesson. We'll definitely focus mostly on those topics so that we are able to remind you, and then you are able to be ready for these exams. Hence, we're saying about 60 minutes we'll spend on mechanics, Doppler effect about 9 minutes, 21 minutes in electricity and magnetism. And then before I start, I want to say revision sharpens your skills. So I'm not coming here with a question paper that you will find tomorrow, but I'm coming here with skills that you will need to answer any physical science question. So our focus in this lesson is exam skills and techniques, to say what are the skills that you need when you find a question like this, because everyone who has the skills will be able to answer questions, no matter it can be new questions. As long as you have the right skills for that particular section, you will be able to apply the skills and you will be able to answer the question. So we're saying this is a chance to prepare for exam style questions. So we're going to look at exam style questions to say this is how questions are asked in the exam, and then this is how we're expecting you to respond. Now, definitely, we always start with our Newton's laws of motion and forces, which is you're expecting this question in the second question there to say Newton's laws of motion. Now, we always start with Newton's first law, which are referred to these two things which are important. The first thing is that F net equals to 0, and then we are saying an object is at rest. The object will remain at rest or moving at constant velocity unless acted upon by an external resultant force. As long as there is no F net that is acting on that object, we are saying that the object will remain at rest or will continue to move at constant velocity. Be aware of these two scenarios when you are answering questions, whether the object is at rest or the object is moving with constant velocity. Remember, if the object is moving with constant velocity, we are saying the forces are balanced. The forces are balanced. We have balanced forces. Then we know that the object is moving with constant velocity. We'll talk about equilibrium there to say the forces are at equilibrium. So the forces can be at equilibrium while the object is in motion. So it's important that you have that understanding to say, okay, when we say the object is moving, but the forces are at equilibrium, are in equilibrium, we are simply saying that the object is moving with constant velocity. So constant velocity, we're saying your forces are balanced. We're saying the forces are in equilibrium. So don't forget all that in terms of Newton's first law. F net equals to 0 newtons. In terms of Newton's second law, we are saying when this net force is applied on an object, the net force is no longer equals to 0. We now, in Newton's second law, have the net force. And we are saying that you have that formula from your data sheet, F net equals to ma. Always is there to remind yourself to say when a net force is applied on the object will accelerate in the direction of the net force. And we are saying that the acceleration is directly proportional to the net force, and acceleration is inversely proportional to the mass. Always you'll write that in weights, and you are able to get your 2 marks. And we are saying in terms of Newton's third law, two bodies, we are saying if an object A exerts a force on object B will exert an equal but opposite force on object A. So you are able to see that this is all the laws that you must be able to state all of them, and that is the expectation as we move. Now we are saying problem solving. When it comes to problem solving here, we are always emphasizing the importance of the free body diagram. Remember, you don't draw the free body diagram for the one that is asked only in the question. You can even draw the free body diagram for you to be able to answer other questions, because without knowing which forces are acting on an object, it will be difficult for you to do this. And this is important because you are going to apply do the free body and force diagrams in question 2, which is your Newton's laws. And when you do your work, energy and power, you will still be able to identify. You need to identify the forces acting on the object in both Newton's laws and work, energy and power. As well, you will be asked the same question can be asked under electrostatics to say draw the free body or the force diagram. So it's important that you have that knowledge of how to go about doing that. And we are saying underline keywords. We have keywords like rough surface. Immediately when you see rough surface, you know we are saying there is friction. Friction is involved. When you say smooth surface, we are saying frictionless, or there is no friction. You know that when you say the smooth surface, we are saying friction is there, but it's very little, in a way that we ignore it. So we are saying that is a smooth surface will be a frictionless surface. A rough surface will have friction. And we are saying pay careful attention to the mark allocation. We are always emphasizing that to say if a question is 3 marks, definitely you know that is a routine question. And we are always saying you will write your formula, you will do your substitution, you will write your answer with correct SI unit and direction. Hence we are saying always say FSAUD to say always remember. We are saying that identify the correct formula, substitute, write the answer with correct SI unit and give direction if you are dealing with vectors. Remember, we always penalize you the mark if you don't indicate the direction, you just show the magnitude of a vector, because a vector has got both magnitude and direction. And then marks more than 4 marks, definitely you know that will be your multi-step calculation. So you're able to see that when it's 4 marks or more, definitely it needs more of you to do the calculations so that you are able to get all the marks. So I'm hoping that will help you as we go to do questions. But we're saying you can't do questions without going through the data sheet. And we're saying when you go to data sheet, you are going armed with data that you have collected. So when you get the statement, you have given information there. You are able to identify all the important information that you are going to address in the data sheet there, so that you are able to choose the correct formula. Because for you to get the mark, you must be able to identify the correct formula and be able to substitute in that particular formula. So we're saying if there is no substitution, you just write the formula. We're not going to mark the formula, because the formula you just took it from our data sheet. Hence we're saying trace this formula. You be able to take information from the statement and write it underneath that formula in order for you to get a mark for identifying the correct formula and a mark for substitution. So if you do that correctly, you will definitely be able to collect marks. And we're saying with our data sheet again, remember Newton's second law. You are able to come here and it will always remind you when a net force is applied on the object will accelerate in the direction of the net force. Don't forget, you make acceleration subject of the formula in order for you to say acceleration is directly proportional to the net force and acceleration is inversely proportional to mass. Then you are able to always use that as a point of reference. And as you look at this data sheet for forces, as well, you are having your maximum static frictional force, and your maximum your kinetic frictional force as well. Your kinetic frictional force, your maximum static frictional force. Then you are able to calculate static friction, maximum static friction, and kinetic friction as well, depending. So if you are given the coefficient of static friction or coefficient of kinetic friction, you are able to calculate each of them respectively like that. And we are saying this formula is very much important because it's a point when you are thinking about doing the calculations, you will always refer here, and you don't come here without the data that you have collected, because the data will always remind you which formula to choose. And we are saying, don't forget as well, we have the gravitational force for universal gravity. We have the force for universal gravitation there, your F. Then or as well be able to utilize that formula as well. And it's very much important when you're dealing with this particular formula to understand the relationship between the force and the mass, and the force and the square of the distance between the objects. So it's important that you see that as long as whatever is happening, the force is directly proportional to the product of these masses M1 and M2, directly proportional, meaning that if we double the M, definitely we're going to double the force. But if we double both M1 and M2, definitely come and substitute there. When you double M1, you will substitute M there, which becomes 2 there. Then you are able to see that as we double the mass, we are able to double the force. The same, if we double both masses, be able as well to do the same. This question is one of the questions that in the multiple choice questions that you will come across, to be able to see that, okay, what happens if we double the mass? Just substitute to say if we double the mass, it will be 2m1 multiplied by m2 over r squared. Then you are able to remove the 2 there. You remain with your g m1 m2 over r squared, which is your force. So you can see that as you double the mass, you double the force. And then if you double m1 and m2, definitely it will be 2 times 2, which means the force will be 4 times more. And then the same, what is the relationship now when we increase the distance? We can double the distance, be able there to always remember when you double the distance, it will be 2r all squared. When you double the distance, 2r all squared, which means now it becomes 4r squared, which means definitely when you are increasing the distance, the force will decrease because they are inversely proportional. But you are able to see that when you double the distance, the force will decrease by 1/4. So you'll be able to get 1/4 force there, that is quarter of that particular force, and be able to understand that if we halve the distance, the r there, if we halve the r, be able to see that when you have the r, where the distance is becoming small, definitely the force must increase. So you are able to see that you must write r/2 squared. So you're able to see that you will get r²/2/4, which definitely is 1/4. And when you multiply that, you will be able to get that the force will increase by 4 times. So know the relationship. When we increase the r, we're saying the force will decrease. But when we decrease the distance between the two bodies, definitely we are saying that when we decrease the distance, the force will increase. So always I wanted to emphasize that, so that you don't lose marks. Even in multiple choice questions, you get such questions and be able to interpret this information. Now, without any wasting of time, today we are more about questions. We are more about how are we going to solve problem solving. It's less of talk, but more of problem solving. And then definitely, as I indicated, I said to yourselves that it's important that you understand that what we are giving you here is the skill of how do you go about responding to multiple choice questions like this one. Now, this one is saying several forces are acting on a moving object. So it's very much important, because you know exactly that we can have a body at rest, we can have an object that is moving. So this one is a moving object. Which one of the following is correct? When the forces are in equilibrium, you are able to know which law talks about the forces in equilibrium. Oh, I just told you about balanced forces. Balanced forces, they are at equilibrium. So you are able to see that, okay, forces, the forces are in equilibrium. It means the forces are balanced. Now, you know when the forces are balanced, which law is that one? Is Newton's first law. Remember Newton's first law? We said when an object will remain at rest or moving with constant velocity unless acted upon by an external resultant force, unless there is an unbalanced force now that is going to unbalance everything. So we are saying now, which law is that? Newton's first law. So the question is saying, which of the following statement is correct for when forces are in equilibrium? So we're saying the velocity of the object is increasing. No. The object is moving at constant velocity. Equilibrium, yes. Constant velocity, balanced forces. Constant velocity, balanced forces in equilibrium. So definitely you are able to get your answer because you have studied and you know your law. So you see that these multiple choice questions, they can be based on application of the laws that you have done already. This was the question, multiple choice questions in 2024 final exam. And then let's look at the second question now, which is multiple choice question again, 1.2 from November 2024. The question was, a stone is thrown vertically downwards. A stone is thrown vertically downwards from the top of the building. Of a building takes time t seconds to strike the ground. Consider the acceleration time graph for the motion of the stone. The effects of air friction are ignored. What does the shaded area between 0 and t seconds shown in the graph represent? So it's very much important for you to have an understanding to say our graphs, they always have the y-axis and the x-axis. Remember, as I emphasized that here we're giving the skill, whichever graph you get, you are able to interpret that graph and have correct information. And then what are we saying? We're saying if you say change in y over change in x, you're going to get the gradient of the graph. That gives you the gradient of the graph, and then which is change in y over change in x. But now, in this case, they are saying now, what does the shaded area between 0 and t, this shaded area between 0 and t shown in the graph represent? So we are simply saying now, for gradient, we say change in y over change in x. But when it comes now to the area under the graph, we are saying now is the multiplication of y multiplied by x. Y multiplied by x. And if you check, that will be acceleration, which is your y, multiplied by time delta t. And A delta t, definitely that is your change in velocity. By definition, you know what is acceleration? We are saying acceleration is the rate of change in velocity. So definitely, if you are to do the cross multiplying there, acceleration over 1, you are able to get delta v equals to A delta t, which now shows you now that you are able to see that. So now it's important when you come to the options, already you know that I'm talking about the area under the graph. It means I'm multiplying A times delta t. And even if you can use the SI unit, you know that acceleration is in meters per second squared. If you multiply meters per second squared by second, which is time, definitely you will get meters per second. And meters per second is what? Is your velocity. So you are able to see that, okay, this graph represents option number 1, A, the final velocity of the stone, B, the change in position of the stone, constant velocity of the stone, change in velocity of the stone, correct. So you see that acceleration is the rate of change in velocity. So this A delta t, which is the area under this graph, definitely will be able to show us the change in velocity of the stone. So you are able now to choose D, and you are 100% that you are able to answer the question. I hope this helps you not only with this graph, with any other graph, to be able to understand that when I say change in y over change in x, I'm talking to the gradient. When I say y times x, I'm talking about area under that particular graph. In this case, the area under acceleration time graph, we are saying it shows us velocity. The same, if we can give you velocity time graph, you will be able to know that the area under velocity time graph, that is now your v times delta t. So you just simply go to the definition of what is definition of your velocity, which is the rate of change in displacement. Definitely that will be your delta x, the area under this particular graph. But if you were to get the gradient under velocity time graph, the gradient, it will be change in v over change in time, which in this case, change in v over change in time is acceleration. So be able to have that knowledge to say, okay, the gradient under the velocity time graph will give me acceleration. But now the area under velocity time graph, definitely it will give me a change in x, my displacement. The area under acceleration time graph will definitely give me change in velocity. So I hope this helps you not only on this question, but for any other question that you will get that is have to deal with graphs like this one. Now, let's look again, question 2. We are having here two blocks of mass 4 kg and block B of mass 9 kg. So you can see, as indicated, they are going connected by a light inextensible string. The blocks are held at rest on a plane that is inclined at angle of 35 degrees with horizontal. A constant force, you can see we have a constant force, is applied, acting parallel to the plane, is applied to block B. And then, as shown in the diagram, the blocks now accelerate with acceleration of 2 meters per second squared. Important for you to be able to underline that critical information that you will need to say, now these blocks are now accelerating, and the acceleration is 2 meters per second squared. Now, state Newton's second law of motion in waves. I hope by now you are singing it, to say when a net force is applied on the object will accelerate in the direction of the net force. And you are saying acceleration is directly proportional to the net force, and acceleration is inversely proportional to the mass. So you are able to write that in your ways, and then you are able to get your 2 marks. Now, the next question, draw a free body diagram. Draw a free body diagram showing all forces acting on block A. All forces acting on block A. So you got to, don't make a mistake. If the question is about block A, draw block A. What are the forces? You can see that already we have a string, and the force that we find on the string, we call it the tensional force. So definitely you will have tension. You have heard here, we have talked about this object that are on this plane, and then they've indicated that the two blocks of mass 4 kg and 9 kg are connected by light inextensible string. The blocks are held at rest on a plane that is inclined at an angle of 35 with horizontal. A constant force F acting parallel to the plane is applied. But the statement that is more important that I'm looking for is this statement: the kinetic frictional force acting on blocks A and B is given there respectively. So if you miss that statement, you'll be missing that there is frictional force that is involved. So it's important that you always look for keywords like those that might be hidden somewhere in the statement. You must be able to see that, okay, we have kinetic frictional forces that were given on A and B respectively. Definitely there is friction. So you can see on block A, we're having tension, we're having our frictional force, and then there is a popular force that is always there, which is your Fg. Fg is always there. When we are drawing our free body diagrams, there will be Fg. It's meaning that you have that one mark of drawing Fg because it's there. And because now we're having the surface, we have the normal force as well. Remember, the normal force must be normal. What do I mean by that? I mean that the normal force must be perpendicular to the surface. Always perpendicular to the surface. So that's how you will draw your tension, your friction, your normal force, your weight. But the most important thing here is that don't be too excited, and not your forces must always start from the dot there. And there must always be arrowheads. And be careful not to draw your arrowheads like that because you are in hurry. And then you find that the arrowhead is no longer in touch with the force that is representing. So those small things, or you find that your line doesn't touch the dot at the middle there, then we're going to definitely take away marks. So those small things, don't be too excited. Remain calm, draw and collect all the marks. And the marks are always telling you, reminding you of the number of forces that we're expecting you to draw. Because it's 4 marks, definitely in your head, you are able to see that we're expecting to have at least four marks. Now, calculate the magnitude of the tension in the string. Calculate the magnitude of the tension in the string. That is for 4 marks. So at least this one is for the tension on the string, and then the free body diagram that you have drawn, it had on the 4 kg, it had the tension. So you are able to see that, okay, the forces that we are having our tensional force going up the incline. We're having our frictional force that is opposing motion in the opposite direction. But now, what is important now is that we have our weight that is at an angle because we're going up the incline. So definitely now you must be able to resolve our weight into the horizontal and vertical component. So you must be able to have your perpendicular component like that, which is your Fg parallel or W perpendicular, and then you have your weight, which is parallel. So you are able to see that your weight or your Fg will have Fg perpendicular and Fg parallel. And we are saying this Fg perpendicular or weight perpendicular weight, we are saying is equals to the normal force. So they cancel one another. So our focus in terms of the forces are the forces that are acting where the object is moving. The object is moving along that direction up the incline. So our focus will be in those forces, and then it's up to you to choose the positive direction. Where tensional force is going can be positive, or where the other 2 forces are going can be positive. And without wasting time, you are able now to do your calculations. To say you have chosen that up the incline is positive, then definitely T will be positive. But if you have chosen that up the incline is negative, definitely your T will be negative. So always choose the positive direction because we are dealing with vectors. And then the other forces acting, a kinetic friction, it will be negative. Your Fg parallel or your parallel component of weight will be negative as well. And that is F net equals to ma. We always apply Newton's second law in this case. And then you are able to do the substitution. You were given the kinetic friction on A, which was 5,88. You were given our mass, which was 4. And then you were given as well, you know G is 9,8. And then don't forget the Fg parallel or the parallel component of weight is mg sine theta. Please don't forget that. Your m for mass, your g for gravitational acceleration, sine, our angle that we given, it was 35. You are able to substitute it there. And with that done, you are able to calculate the tension. You just simply make the tension subject of the formula. Everything goes transpose that side, and then you are able to collect all your marks. I hope it helps you. Whether you have chosen up the incline is positive or negative, the two are sure. The next question was on the force. Calculate the force F, and then you have seen that force F was acting on the 9 kg block, which in that case there was a tension as well that was pulling the 4 kg block. So now, meaning that now you must be able to have a free body diagram or a force diagram that will show you all the forces acting on the 9 kg block. I just want to emphasize here that don't make a mistake of using the system approach, because we're going to penalize you. So you apply Newton's second law to the 9 kg block alone. If you get the answer, it's fine. If you don't get the answer, you will go and apply the Newton's second law on the 4 kg block and then simultaneously be able to solve until you get the answer. In this case, we applied F net equals to MA on the 9 kg block, and then we said the forces now that are acting on the 9 kg block is the applied force, which we had positive in this direction. We have tension that is opposing the motion going backward. We have kinetic friction. We have the parallel component of weight. So you are able to see all those forces that you have identified, and then that is equals to MA. Immediately when you do that, you rest it, you substitute, and after your substitution, you are able, don't forget the mass is no longer 4 kg, we're talking about the 9 kg, and then just use the calculator, you get your correct answer. So I'm hoping you will practice as many of those questions as you remind yourself. This you have done in grade 11, you have revised in term 2, it was part of your junior exam. Even now, as you prepare for your prelim, you are still doing this, and definitely you must be able to collect these marks. Now, without any wasting of time, we will move to vertical projectile motion. You know your exam guideline, which you said that's your Bible. You have it close to you. You have it with you all the time. You keep it close to yourself, because as you are revising, you are having the exam guideline. You are able to tick what you already know. Now, the exam guidelines say you can explain what is meant by a projectile. Remember, we're just saying a projectile is an object upon which the only force acting is the force of gravity. Remember, we are saying that our projectile has been given an initial velocity. It has been given an initial velocity for it to be a projectile. We said it has been given initial velocity, and the only force acting upon it is the force of gravity. And then when you differentiate from free fall, we're saying projectile is an object which has been given initial velocity, and the only force acting upon it is the gravitational force. And then when it comes to a free fall, we're saying this one now, we are referring now to an object. We are referring to motion. So projectile is an object that has been given initial velocity, and the only force that is acting upon it is the force of gravity. And then we are referring to free fall as a motion, of which the only force acting upon it is the force of gravity. And we are saying be able to remind how to sketch those graphs, be able to, for all the scenarios, be able to draw the graphs, be able as well, when the graphs are given, to determine the velocity, to determine the position, the displacement, and position. And then we are saying bouncing ball, the bouncing ball as well, you must be able to know how to do the calculations. And then the object that is thrown upwards, and the vertically upwards, and the object that is thrown vertically downwards. You'll see we're going to do the questions now, and then you must be able to remind yourself about that. I've emphasized what a projectile is to say this one is an object. And then when it comes to free fall, we said this one is motion. What is an object? What is a projectile? We said it's an object which has been given an initial velocity. Write it in full. And then it moves under the influence of gravitational force only. But when it comes to free fall, we are saying this one is motion during which the only force acting on the object is the gravitational force. So we are saying at least these two definitions for this question on vertical projectile motion is a song. You must be singing them by now. But our data sheet, very much important. Our equations of motion, that you know them. The graphs, I've emphasized that you must be able to draw the graphs. And then, as always, problem solving strategy in terms of this particular question, we are saying put critical points in your trajectory. Always start by drawing the trajectory, followed by the projectile. So draw it. You know, they say seeing is believing. So when you see something, at least you know what is happening because you have seen it. You have seen it. When you have seen something, when you draw something, you start to see it. And when you see it, you'll be able to answer questions based on it. And we are saying as you draw your trajectory, be able to put critical points, the point of launch, the maximum height, point of launch as being A there, the maximum height, you know at the maximum height we are saying velocity there is 0. And then point symmetrical to the point of launch, C there. The symmetry. Remember we talk about the time symmetry and the velocity symmetry. To say from A to B, the time is the same as time from B to C. So we talk about time symmetry. So if I know time from A to B, definitely I know time from B to C. And then we talk about the velocity symmetry as well. To say if I know the velocity at A, it means I know the velocity at C. The difference there, it is the sign. It is the sign. If upward is positive, it means time at A will be positive, but time at C will be negative. So those small things, they're important. And to say as we pass C, we are expecting that the velocity is increasing. So definitely those are things that you will always take into consideration. And we are saying choose sign convention. Always tell us which one is positive. Choose the positive direction and do your data collection. You have 5 variables under equations of motion. It's your initial velocity, final velocity, acceleration, change in y, and change in time. Definitely the rest that table, collect the data before you answer the questions. And then we are still emphasizing here the constant magnitude and direction of G. To say G is always 9.8 meters per second squared downwards. Please don't forget that. Always remember that. And we are still emphasizing the formula, substitution, answer with correct SI unit and direction, but direction is only for vectors. So without any wasting of time, let's go to questions. As I indicated, we want to focus mostly on dealing with questions. Let's look at this one. A person dives from a high platform into a pool at which one of the position A, B, C, D will the magnitude of his momentum be a maximum. So you can see that this question, it is integrating the topics, because as we were doing vertical projectile motion, we had an understanding. We talked that when we start at D, definitely this is our projectile. It has been given initial velocity. Now you can see our object here is a person. He's diving. So here he's diving. From there, with initial velocity, goes up, reaches maximum height, then it starts to fall there, going down. Now you can see that if I draw a point here, maybe let me call it D1, so that you are able to see. We talk about velocity symmetry. To say the velocity at D and the velocity at that point of launch, that is the same point of launch. When the object reaches there, the velocity is the same. So you are saying if I left here with 10, it will decrease to 0, but it will become minus 10 here, which is equal in magnitude, but in different direction. Definitely, as I pass point D, definitely the velocity is starting to increase. It's always more than 10. It increases until A. Just before the diver reaches the pool, definitely will have maximum velocity. So at which point, the question was, at which will the magnitude of his momentum be maximum? At which point? So you are able to see that at A here will have maximum momentum, because momentum is equals to mv. So when v increases and we have maximum v at A, definitely the momentum will be maximum. So that is your integration as well of topics. And then let's take now a previous question paper as well and deal with it in order for us now to revise our vertical projectile motion. Now a ball is dropped. So already you can see a ball is dropped. from rest. From the top of the building, 15.2 meters high. After a ball has fallen 3.2 meters, a second ball, so it's not only one ball, the first one was dropped, initial velocity is 0. So you know here that it was dropped. Dropped means initial velocity is 0 meters per second. And then the second ball, which is B now, is projected. Initial velocity cannot be 0 here because now it's projected upwards. So it has initial velocity. And then after a while, the two balls strike the ground at the same time. So what is important is that these balls, they are going to strike the ground at the same time. Ignore the effects of air friction. You know the importance. I think when you see that statement, you are the happiest, because that statement is saying the only force that is acting upon these objects A and B, is the gravitational force. So that statement is there to qualify, to say we only have one force acting on A and on B, which means these two objects are undergoing free fall. They are undergoing free fall. Remember, free fall, we said, is a motion. It's a motion of which the only force acting is the gravitational force. So they are saying define free fall. You're saying, oh, free fall, yeah, these two objects, they are all under free fall because the only force acting upon them, is the gravitational force. And you can see B, you see that it's a projectile. It has been given an initial velocity, because we're saying a projectile is an object that has been given initial velocity, and the only force acting upon it is the force of gravity. So I think you are seeing the whole topic here. And then the first question was, calculate the time taken, 3.2. Calculate the time taken for the ball to strike the ground. Ball A. So important to know which ball you are responding about. Don't confuse all of them. And then immediately, when you talk about A, you are able to say, okay, what do I know about A? What do I know about A? I know that initially it was dropped. A was dropped. That is the first thing that you know. You know that change in Y is 15.2. You know that gravitational acceleration is always 9.8 meters per second squared downwards. You don't forget that magnitude and direction of gravitational acceleration. So you can see in your data collection a lot of information. And the question is saying, no, all we need is time. We want to know the time that it took for ball A to reach the ground. So armed with this data collection, you are having your delta Y, you are having your initial velocity, you are having your gravitational acceleration, then you are able to go to the data sheet. Remember, you must be able to choose the positive direction. Now, without wasting time, definitely you go to the data with your to the formula data sheet. You are able to choose change in Y equals to VI delta T plus half AT squared. Definitely, when you choose upward as positive, the object was going down. Definitely, your change in Y is minus 15.2 is downwards. Your G is negative 9.8. So it's very much important to see that, when I say upward is positive, G is always going down. Definitely G must be negative. Then you are able to do that. And then you are able to trace your formula. Remember, we said initial velocity was 0. Then you are able to say 0 times delta T is 0. You have half minus 9.8 times delta T. So you solve for delta T, which in this case is 1.76 seconds. Then your routine questions, 3-mark question, formula, substitution, final answer, and then you are able to get your final answer. I don't want to waste time. We must be able to move. Remember, we are trying to revise as many questions as possible for paper 1 so that you are ready. Now, they are saying now, calculate the magnitude of the velocity which the ball was projected from the ground. Now they are coming to B to say what was the initial velocity for this ball, B. And then you are able now to say, okay, let's go about it. Definitely, data collection, you know for ball A, what we know about A is that A was able to move 3.2 meters before B was projected upwards. A moved for 3.2 meters. So now that piece of information is very precious, because we want to be able to now to find now the time that it took for A to travel for that particular one, so that we calculated the total time there from there to here for ball A. We said that time is 1,76. So now, if we know the time taken by A to travel 3,2 meters, definitely we can subtract that to get the time that took ball B to reach the ground. So you see now, we are using what we have to get what we want. Definitely, we substitute, you choose your position, upward is positive. Remember the implication, change in Y is negative, acceleration is negative when you said upward is positive. Then you are able to substitute, or you are able to do your simple substitution there, and then you are able now to calculate your time to say minus 3,2 for my change in Y, and then remember we're still talking about A, initial velocity was 0. What was the time? 0,81 seconds. So once you know that it took this ball 0,81 seconds, then you can find the total time traveled by B by simply subtracting 1,76 minus 0,81, because it was only when the ball A reaches has traveled 3,2 when we launched ball B upward. Now, from there, you got the time it took for ball B is 0,9 seconds. Now, for ball B now, you are able to see that, okay, change in Y, it went up, then it came down. Our change in Y is 0, and then you are able to write your time, which is 0,95. So it's very much important that you can't use 1,76. You only use the time that B traveled, which is the time taken, which was 0,95. Then definitely when you do that, you are able to get your initial velocity, which is 4,66 meters per second as the initial velocity of ball B. Now, as we move forward, we're able to say the last part of the question now, which is on the same system of axes, draw position time graph to show the position of ball A and ball B from the instant the ball A is dropped until the time it reaches the ground. Take the ground as a 0 position. Very much important. Label the graphs A and B. So the graph for ball A and the graph for ball B. Clearly indicate the following on the graph. The starting time for each ball. The starting point from each ball, the initial position of each ball, the time when the ball strikes. So important, initial position. Remember, the ball was from the ground, 0. Remember, the other ball, ball B was from the ground when it was projected upward. The ball A was from 15,2 meters. You see, all that information important as you draw a graph to say where is ball A going to start from 15,2. Where will ball A start? Ball B start from 0. So you are able to do that. You can see ball A is starting from 15,2. How long did it take to reach the ground? 1,76 seconds. You see, that's where your marks are. For ball B, it started from 0. It went up and then stopped at 1,76. So we know the time taken by that, we said is the difference of that. And then you are able to draw. So you can draw the graph for upward as positive. Remember, for upward is positive. You draw as the statement, the ball is dropped. So you can see the ball is being dropped, it's going down ball A. When it reaches that, ball B was now projected upward. So you can see this is what is actually happening. When you choose upward is positive. However, when you choose downward is positive, it's just upside down of what really happened. So be able to choose the correct direction. But I think it simplifies. The upward is positive, simplifies you, and then you are able to get your 5 marks. Very, very important that you do that. Now, we look at linear momentum and impulse. Linear momentum, we're saying here, there are important definitions that you must always remember. Remember momentum from the data sheet. P equals to mv. You're saying the product of mass and the velocity of an object. And then Newton's second law in terms of momentum. Remember, you have done that one as well. F net is equals to the rate of change. Rate of change in momentum. You have done the impulse, which is the product now of the net force, and delta t, this one, the product of the net force acting on the object and the time taken when that force is acting on the object. F net delta t. Immediately when you cross multiply there, you get your impulse. Isolated system, remember you were saying there are no external forces acting on the system. The principle of conservation of linear momentum, I always emphasize this one to say, as long as it's saying principle of conservation, definitely you will say the total linear momentum of an isolated system is conserved. Total linear momentum of an isolated system is conserved. If they say the principle of conservation of mechanical energy, definitely the total mechanical energy of an isolated system is conserved. You must be able to show the elastic and the inelastic collision. Remember, for elastic collision, we are saying both the momentum and kinetic energy are conserved. But when it comes to inelastic collision, only momentum is conserved, but kinetic energy is not conserved. And we are always saying, when you get questions that you have to show whether the collision is elastic or inelastic, calculate the total kinetic energy initially, separate, and calculate the total kinetic energy finally, separate, then compare them after. Don't say they are equal when you are starting with the calculation, because you don't know whether they will be equal at the end or they won't be equal. So that's what I will remind you. And then in terms of this, already I've indicated all this in the previous slide. And then the tip there is just say, please, let's always read the scenario carefully and underline the key. Let's underline the keywords. And then remember, we are talking about velocity, we're talking about momentum, change in momentum, and average force, which are all vectors. And you know that with vectors, always we're taking direction into consideration. And we're saying always refer to the data sheet when carrying out the calculation. And we're saying pay attention to the mark allocation. I've said that. I've talked about elasticity of collision, whether it's elastic or inelastic. And then we talk to that. Now, work, energy, and power, which is the last topic in terms of mechanics. Remember, we said in mechanics we are talking about plus or minus 65 marks here, and then you have work, energy, and power. And this topic you started in grade 10, so it's always important that you remember that in grade 10 you have defined the gravitational potential energy as the energy that the object has due to its position. And then you said isolated system, I talked about it to say there is no external forces acting on that particular system. Kinetic energy, the energy due to the motion of an object. And then the law of conservation of energy. Energy cannot be created nor be destroyed, can only be transformed or transferred from one form to another. Mechanical energy, when we talk about mechanical energy, we have emphasized that is kinetic energy plus potential energy. So you know that that is your mechanical energy. When you say the principle of conservation of mechanical energy, you are simply saying total mechanical energy in an isolated system is conserved. Please always have that in mind. Definitely it will help you. Now, on the work, energy, and power, we said the following definitions, always know them. Always know them to what the work done. It was asked last year, final exam, this question to define the work done. So definitely you got to know that there must be a force that is acting upon the object, and the object must move in the direction of the force. So you are able to always remember that your F delta X cos theta as you define work. Is there in your exam guideline? Define it as is written. The positive work done versus the negative work done. Remember, we're talking here about the angle between the force and the delta X. To say if they are parallel in the same, the force and delta movement in the same direction, we're talking about cos 0, positive work done. But when the force, like friction, opposes where the object is moving, cos 180, and cos 180 is negative work done. So always know that. And when the force is perpendicular to the movement or to the displacement there, we are saying that now there is no work that is done. And then you must know the principle of conservation of mechanical energy, the principle of conservation of energy, the work energy theorem, as given in the data sheet, work net equals to change in kinetic energy, be able as well to state it. And then your conservative force. We're talking about here the work done in moving the object from one point between 2 points. The work done in moving the object between 2 points. This one independent of the path taken, and then the non-conservative one dependent on the path that has been taken. And we are saying, remember power. We are saying power is the rate at which work is done. The rate at which work is done. Remember as well, we talk about power when we talk about work done, we're talking about the energy transferred. So the learners know that it can be the rate at which energy is transferred there as your power as well. And remember, when we're having average velocity, when we're having constant velocity, we are saying now our power is FV average. So you know that formula as well. So all this information is important as you will be doing the calculations that are based on these topics of work, energy, and power. I have already indicated the issue of the positive work done, the negative work done. Positive work done, we said when the force and delta x in the same direction. No work done, we said when the force and the displacement are perpendicular. And then negative work done when the force and the displacement are in opposite direction. If is cos 180, you can see this one is cos 0 degrees, cos 180 degrees, and then cos 90. Definitely you can use your calculator. Cos 90 will give you 0 work done. So you are able to know when do we say positive work done, negative work is done, and no work is done. Now there are steps as well to follow when you are dealing with calculations based on work, energy, and power, which in this case is your free body and force diagram. We talked about them when we talk about Newton's laws. We talked about the issue of the data sheet. There is the data sheet for work, energy, and power. If we say define work, definitely you're going to refer to that formula as well. And then mechanical energy, mechanical energy, power, we are given. So all this is important. And then when we have a constant velocity, we can calculate our power there as well. So the data sheet is important. It's an important piece of information, because when you are stuck, you are able to go to the data sheet with data collection. You collect data before you go to the data sheet. Then the data sheet will definitely help you to see which formula is going to help you in terms of answering the questions. As indicated, just to show a question here, the diagram below shows a track ABC curved section AB, which is frictionless. The rough horizontal section BC is 8 meters long. So you are able to see that we are moving now AB. This one is no friction, frictionless. And then this one has friction. So you are able to see that. And then you are able to, the rough horizontal section BC is 8 meters long. State the principle of conservation of mechanical energy. As I said, you will say total mechanical energy in an isolated system is conserved, or the total mechanical energy is conserved in an isolated system. So please be able to collect those 2 marks. Is mechanical energy conserved as the object slides from A to C? So mechanical energy can only be conserved if we have no the conservative forces. If we have conservative forces, definitely mechanical energy will be conserved. But immediately when you have forces that are not conservative, like friction, mechanical energy will not be conserved. So from A to B, mechanical energy is conserved, simply meaning that you can use the principle of mechanical energy to solve questions based on A, B. But when it comes to BC, definitely we have friction, so you cannot use mechanical energy. You will use the work net or the work done by the non-conservative forces. So it tells you as well which formula to tap to in order for you to answer the question. So the answer there will be no, because we have the non-conservative forces acting there. Using the energy principles only, calculate the magnitude of the frictional force. So they want us to calculate the frictional force exerted on the object as it moves along BC. So you can see the number of marks is telling you that this is a multi-step kind of question. Now you can use worknet. Remember we're talking about BC. Worknet equals to change in EK, and then that will give you, we have our FG there, delta H cos theta there as we move there, which is half mv squared, and then you are having the substitution and be able to get the final velocity that A will, for A to reach, the object to reach B here, from A to B. So you can see we've used the 4 there because we're talking about here, that part of the motion. We find the final velocity there. And then you can substitute the final velocity now in the path work net equals to change in kinetic energy. Then you know that on this one, which is BC, along BC now, as we move here, we are saying we have friction as our force. So is our work done is F delta X cos theta, which is equal to change in kinetic energy. That is for BC. And then without wasting time, you are able to substitute to say, okay, our delta X was 8. Our is cos 180 because frictional force, we said, is opposing the motion. So it's cos 180 degrees. And then that is equal to half 10. That is our final minus initial, which is from B here. We got that is 8,85. So you're able to see that that is now how you're going to go about calculating your frictional force, which in this case, it is 48,95, definitely in the opposite direction. Now, Doppler effect, which is, as promised, we said we'll spend 1 hour in mechanics, and we did just that. And then in our last 8 minutes, we'll be able to do Doppler effect and look at electricity and magnetism, some part of those topics. And then under this one, which is Doppler effect, I know you are very confident about Doppler effect, but we are saying most of the time learners become more excited about the topics that they understand better, and then they end up losing marks. So take care of this question. It will take care of you. Collect these marks based on Doppler effect. Our exam guideline as well, it has given us that Doppler effect as the change in frequency of the sound detected by the listener, because the sound source and the listener have different velocities relative to the medium of sound propagation. Definitions, definitely you got to know all the definitions. And we must be able to explain the change in pitch observed when a source moves towards or away from the listener. We must be able to solve the equations using the Doppler effect equation. And we are saying always first start by copying the formula as it appears in the data sheet, and then you can be able to check whether it's towards or away and make the necessary changes. Either the source or the listener is moving, so they're not moving together. It's either the source or the listener. So you must always check which one is the source moving or the listener. The other one is zero, the other one is moving. Always check for that. And they were saying you must be able to state the applications of the Doppler effect. And they were saying with light redshift in the universe, evidence for the expanding universe, you must be able to explain the redshift and use the Doppler effect to explain why do we conclude that the universe is expanding. So all those you are expected that come tomorrow when you write the paper, you are able to do all that. Now, we talked about the equation. You will copy as it appears in the data sheet. And we are saying now, this is a combination of 4 equations. So now, a moving source approaching a stationary listener. That is the first we can have when a moving source. So you check the source is moving, the listener is stationary. So you are saying V over V. When then it's approaching, remember, when you're approaching, you are expecting that the frequency of the listener for approaching must increase. And then for it to increase, this one must be negative there. So like that, multiplied by Fs. So you're able to, now after you've done that, you look that, okay, approaching a stationary listener, you will write 0 for the stationary listener, and then it's approaching. We want the denominator to be smaller because the frequency must increase. Then it definitely is plus over minus, plus 0 over minus in this case. And then moving away, definitely for moving away, a moving source, it is still the source moving, so meaning that the listener is stationary, so it will still that, but for moving away it will be plus that because you are expecting the frequency of the listener to decrease. And then the moving listener approaching a stationary, you do the same now. You are now, when you say the stationary source, it will be 0 there, and then you are changing the denominator. Now, the wave equation as well, you are definitely going to use it. And then we are saying a higher frequency sound has a higher pitch and lower frequency. I wanted to say a higher frequency sound has a higher pitch and a lower wavelength. Remember, wavelength, according to this formula, V equals to F lambda. We are saying as the frequency increases, as the wavelength decreases, the frequency increases. So that is the relationship. They are inversely proportional to one another. So that's how we are moving in terms of that. Now, activity based on Doppler effect. We're saying an ambulance moves away from stationary listener with a constant velocity of 25 meters per second. The ambulance siren emits sound waves at a frequency of 550 hertz. The listener detects the frequency of these sound waves to be 512,64 hertz. Ignore the effects of wind. Important. I've underlined all important information because we are going to need that as you go to the question. State Doppler effect as is given in the exam guideline. The change in frequency of the sound detected by a listener because the sound source and the listener have different velocities. We said it to say the other one is stationary, the other one is moving. Hence we are saying they have different, the listener and the source have different velocities relative to medium of sound propagation. So please be able to state Doppler effect. And we are saying use the given information to calculate the speed of sound in air. Very much important. You are saying the ambulance is moving away. Source away. The source is moving away from a stationary listener. You see a lot of information there. The listener is stationary, which means that now you have the speed of the source of the listener as 0 because it's stationary listener. What is moving is the source, which is the ambulance. It's not stationary, it's moving. And we are saying it's moving with what? With a constant velocity. So you are given the velocity of the source here as 25 meters per second. The ambulance emits sound waves at a frequency. So that is the frequency of the sound, which is 500 of the source, which is 550 hertz. And then the listener detects the frequency of this as 512. So you have the frequency of the listener. So with data collection, already you know the formula. You just be able to choose do the data collection, frequency of the listener, the speed of the listener was stationary, the frequency of the source, the speed of the source, and the speed, the V, that we are asked to calculate. So with no any problem, you will definitely choose the correct formula. Immediately after choosing the formula, you start now to do the substitution. You will get a mark for the frequency of the listener, frequency of the source, the speed of the source, as well as the 0 there. You said 0 for that one. So you're able to get your 1 mark for the formula and then 3 marks for substitution, and your final mark for the correct answer, which is 343.04 meters per second. So I hope that helps you as we move forward. Now, the next question says, if the ambulance moves away from the stationary listener with a constant velocity which is greater than, so it's just increasing the velocity now, more than 25. How are 25 meters per second? How will each of the following change? Choose from increases, decreases, or remain the same. So your answer is either increases, decreases, or remain the same. You can't say any other thing because you were told that that's what you must. Speed of sound in air. Remember, speed of sound in air must be a constant. So it must be able now to remain the same. Number B, the frequency of sound waves emitted by the siren. The siren is emitting a sound there. Is it changing? Definitely no. It must remain the same. The frequency of sound waves detected, that's the one that is changes, the one that is detected by the listener, because the source now was the one that is moving away. Now it's just increasing the speed that it's moving with. What will happen to the frequency of the source? Definitely the frequency will decrease because it's moving away even much faster. So it decreases. And then without wasting time, in terms of the redshift, the spectrum of distant star when viewed from the Earth is redshifted. Immediately when you talk about redshift, you have the understanding now to say, okay, we're talking about higher wavelength, lesser frequency. So you can see the sky is blue. Why? Because we are having a shorter wavelength. So we are much closer to the blue part of the spectrum than the red part of the spectrum, which is having highest wavelength now. So you are able now to answer questions based on that, to say now, is the star moving away or towards the earth? So you know, towards the earth, you are moving towards the blue part of the spectrum. But immediately when you talk about redshift, you are talking about moving away from the earth. Now, use the Doppler effect to explain the answer to question 6.2.1, which is what I was saying, to say a lower frequency or a longer wavelength is detected. So longer wavelength as we move to the red part of the spectrum. So you know, we talked about our Roy G. Biv, and then you know that with these ones they have the highest wavelength but lowest frequency, meaning that lowest energy. But when it comes to this blue, violet, indigo, this type of colors, this side, they are having now the shortest wavelength, but they have the highest frequency, highest energy. So you are able to have that relationship, and it helps. Redshift, we are saying now, is a longer wavelength, which is now a longer wavelength, which is now a lower frequency. So now the spectral lines are shifted to the red end of the spectrum. Now that is your Doppler effect. Please don't forget, we only do red shift, we don't do blue shift. Now, electrostatics. Now this is part of the electricity and magnetism part of our lesson. It's important that we always remember the principle of conservation of a charge. Remember, I said everything that is a principle, you are simply going to say the total number of charges in an isolated system remains constant. Coulomb's law. Remember, we're talking about the electrostatic force of attraction or repulsion, which is directly proportional to the is given there, to the product of the charges, and inversely proportional to the square of the distance between them what the charges. So if you have forgotten, just come there, you are able to see Coulomb's law there. Same things that we apply. Don't confuse the universal force of gravitation together with Coulomb's law, because with Coulomb's law we're talking about the product of the charges, and then with universal gravitation, law of universal gravitation, we are talking about now the product of the masses. So it's the mass when you talk about the universal gravitation, it is the charges when you talk about electrostatics or our Coulomb's law. Don't forget electric field. We're saying it's a region in space where a charge will experience a force. And electric field at a point, we said it always, you will go there. So these four definitions, you got to be singing them, because definitely you will get a definition, a two or one of those in your paper. To say now where you are given electric field, so you are saying force per unit positive charge. Force per unit positive charge acting on that particular a point. So you're able to know all these definitions, and you will be able to correct your marks. So I wish you all the best when it comes to electrostatics. But let's look at questions that relate to electrostatics. You are having 2-point charges X and Y that are held. They are 0.03 meters apart, as shown in the diagram below. Or you want to see the diagram. So you are having the charge, which is X, is minus 7.2 times 10 to the power of minus 9 coulombs. You are given another charge which is positive. So then you have a negative charge and a positive charge. And unlike they attract one another. And the distance between them is 0.03. So you are cruising, state Coulomb's law with not any waste of time. You are able to state Coulomb's law. The magnitude of the electrostatic force exerted by 1-point charge on another point charge Q2 is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Between them what? Charges Q1 and Q2. So please always remember Coulomb's law. If you have forgotten, go to the data sheet, you will find that formula, K, Q1, Q2 over R squared. You are simply removing the equal sign together with the constant, proportionality constant there. Then you just say like that. The magnitude of the electrostatic force exerted by 1 point charge Q1 by Q1 on Q2 is directly proportional to the magnitude of the to the product of the magnitude of the charges, and inversely proportional to the square of the distance between them. Be able to state that, it will definitely help you. Now, draw the net electric field pattern due to the 2-point charges. So you can see these ones are going to arc because you are having a positive and a negative, and unlike they attract. Definitely there must be attraction, but the criteria is important that we always talk about it, to say it doesn't mean that on your paper you will always find positive and positive. Sometimes you'll have a negative and positive. As we are having, we bring them together. When you bring them together, remember you are going to say Q1 plus Q2 over 2. So you're going to add them together, divide by 2, and then they will have a new charge. And we can ask you now to draw the electric field pattern after they've touched. Remember, immediately when you bring them together, they will have same charges, which means now they will never be able to attract one another. They will repel one another. So be careful of that, to say, okay, these ones, they never touched. But if they touch, they will have the same charges, meaning that when you draw your electric field patterns, they will repel. And you will know that we are always moving towards the negative. Hence you see the arrowhead is towards the negative and away from the positive. So positive shows repulsion, negative attraction. So we're saying you will get 1 mark for correct shape, you will get 1 mark for correct direction from Y to X. Another 1 mark, lines must not cross, they don't touch one another. Please, these charges, they must not touch and they must not cross. So you must draw something clean like that. And then if they were the same, you will check. If they are both positive, you must be able to draw. You know that for positive, we are saying they will go away. So if they are repelling, they must not touch. They repel, the arrows must go away. Then you draw another positive again. Then they are repelling like that, and they don't touch, and line like that, like that, like that. If they are negative, the arrows will go towards, because we say positive is attraction, negative is repulsion. So for positive, the arrowheads must point out. So when you have like terms, like charges, they will behave in that way. They won't attract, they will definitely move away. And because it's positive, the arrows will be outward like that. For negative, the arrows will be inward. So no for both, because we are not aware whether you will get positive charge, negative charge in the exam, whether both are positive, both negative, or there are one is positive and negative. Like in this question, it was 1 positive and 1 negative, hence they attract one another. We draw them like that, and the marks are as we indicated. Now 2-point charges, which is your X and Y, are held 0.33. That is the statement that we're given. Let me go straight to the question. Now they are saying calculate the electrostatic force that Y exerts on X. Definitely this one is straightforward. They want the force. Definitely is the force of between X, QY and QX. So you just write the electrostatic Coulomb's law there. You write the formula. After that, substitution. Don't forget, calculator here. Calculator, use it correctly. And we are saying don't change the calculator. Always use that calculator you are using, because you got used to it. And then you are able to substitute and you are able to write your answer. You can see as we substitute here, we don't indicate the negative sign on the 7,2. We just write it as 7,2 for the X there. It's just 7,2. So please, you don't have to indicate the negative there as you do the calculations. And you are able to get your marks there, your 4 marks. And then the other question was draw a labeled vector diagram. You see, you can be asked now to draw a labeled vector diagram to show the direction of the electric fields at the point where X is positioned. And then you are able as well to now, because you can see now we have brought in a third point, which is Z. Z, this side of our non-positive charge, is positioned 0.01 meters to the left of charge X. So it's 0.01 in that direction. So they're saying draw a labeled vector diagram to show the direction of electric fields. Then you can draw EY and EZ. Between EY and EZ, you are able to see that you are having your EZ in that direction, and then EZ in EY and EZ, and then you can draw them like that to show your EY and your EZ, or you can draw them like that. But you can see they are in opposite direction, EZ and EY, as you were asked to draw all of them at point where X is positioned. So where X is, it will definitely get the Y in that direction and the Z in that direction. So you are able to get your 2 marks. And then the magnitude of the calculate the magnitude of the resultant field at point X is positioned is 4, so you are given electric field at point X. Yeah. Is 4,91 times 10 to the power of 5 Newton per coulomb. Then they are saying here, calculate the magnitude of charge Z. So you must be able now as well to use the E net. Remember, E net, when they are given horizontally like that, it's easier. You will say EZ due to Z and due to Y. So you're able to add the two, and then you're able to show that, okay, its repulsion is EZ minus EY, and then you are able to write them E net equals to, then you write the two formulas there. Don't forget the negative there. And then you are able to substitute your E net, which was given as 4,91. You were given as well, but you didn't know the charge of Z. It's just what you are looking for. So you substitute everything that you were given, your 0,03, your 0,01 for the Z there, and then you're able to calculate the charge of Z. So calculate, you can be asked to calculate, to do such type of a calculation, and then I hope that helps you. Now, let's look at electricity or electric circuits. And then we are saying the following definitions are important in terms of electric circuits. Remember, learners, you have done potential difference in grade 10, and then SW V equals to W over Q. The work done on moving a charge from one point to another. And then now, when you talk about now EMF, we are now bringing what is called maximum there. Well, that is the maximum energy. Remember, work done is energy. Maximum energy supplied by the battery per coulomb charge of a coulomb passing through it. So you got to know how to define EMF as the maximum energy supplied by the battery per unit charge of a coulomb passing through it. And then you are able to define that. You must be able to know now Ohm's law. Remember, we are saying our potential difference is directly proportional to the current, provided that the temperature remains constant. So you are having those two. So okay, these two, they are directly proportional, provided that the temperature remain constant. And we are emphasizing now that, remember, we have the series and parallel. And now in grade 12, we have introduced the internal resistance, which you have done experiment, even if you didn't do the experiment, but you know the internal resistance, which is your when you're using the EMF formula, is I R plus R. So you know this small r, which is your internal resistance now, which brings the twist to the whole thing. And we are saying, you know, power, you have done power, is the rate at which work is done. Remember that work we said is energy transferred as well. So be able to remember that power that we're talking about, and you can be asked to calculate power. Now, your data sheet, which is very, very useful for you, you have there your R equals to VI, and then you have your EMF there. Always expand the EMF formula there to say, okay, this EMF for our learners, let them know that we can say is IR plus IR. Let be able to say as well V external, this is your potential difference, plus V internal, that is your EMF. So always have that in mind when you look at this particular formula of EMF. And then we are saying you'll be given resistors. Some of them will be in series. You will definitely do the adding of them. Some of them will be in parallel, and that's how you will deal with parallel ones. And then you have done this, the definition of a current, which is said is the rate of flow of charges, which in this case, the charge equals to I delta T. We talked about your work, your energy, which is your VQ, your VI delta T, your I squared RT, your V squared delta T over R. And then your power, which is P equals to W over T, which is P equals to VI, P equals I squared R, P equals to V squared R. So these formulas, you must be able to apply them to given scenarios that you will be having. Now, let's look at the question. We're given here, the circuit diagram below shows a battery with an EMF of 12 volts and an internal resistance of 0.5 ohms. Connected to 3 resistors, a light bulb, a switch, an ammeter, connecting wires. The ammeter and connecting wires have negligible resistance. Yeah, for all our calculations, we're saying we are ignoring the resistance of the wires and the ammeter. Now, it's important that you look at this as a journey. When you are taking a journey, you always, we said positive. Positive is the big one. The bigger one is positive, negative is the smaller one. So you know that this is your negative, this is your positive. And we're talking about conventional current. So our current is flowing from positive to negative, hence it's moving in this direction. But we are saying now, these 12 volts that we are having, which is the maximum energy supplied by the battery per unit charge of a coulomb passing through it. We are saying these 12, we are going to spend it internally first, because there is internal resistance, meaning that when the charges leaves the battery itself, they are leaving not with 12 volts, because we have internal resistance. So we must pay, as part of these 12 volts must be paid internal. Hence, when we leave here, we're going to leave with less than 12 volts because there is internal resistance. Remember, when there's no internal resistance, when we start our journey with 12 volts, we'll move around with 12 volts. But with this one, when we leave the battery, we are living with less than 12 volts because there is internal resistance, meaning that we must make a payment first to compensate for that internal resistance. I think you have the understanding there. And then we are having our ammeter, which is measuring how many charges are passing every second there. So as our charges will be moving with a voltage of less than 12 volts because of internal voltage, we are saying as they reach this point, there are two different roads to take, meaning that not all the charges will use the same direction for movement. Hence, our current will be divided because we are having resistors that are in parallel. And when resistors are in parallel, they divide the potential, they divide the current. They are current dividers. Resistors in parallel are current dividers. And resistors in series, you see this 10 ohm light bulb and this 10 and 10. This 10 ohm is in series with these two. So these two are in parallel with one another. But when you get their parallel, their effective resistance is in series with the 10 ohm. And then you are able now to say this 10 plus the effective resistance of these two, they are in parallel with the 50. Then you are able to have that. So we're saying current is going to be split when it moves there. Now, without wasting no time, let's move to it. Switch S is initially closed. So our switch is closed, as you can see there. And then we are saying state Ohm's law in weights. So you must be able now to state Ohm's law in weights for two marks, which we are saying the potential difference across the conductor is directly proportional to the current in the conductor provided or at constant temperature. Temperature must remain constant for Ohm's law to state. So it means immediately when we talk about ohmic conductor and non-ohmic conductor, when the temperature now starts to increase, then you know that the conductors now won't obey Ohm's law. Hence, when you draw a graph, it will now start to be a curve, no longer a straight line between current V and I. So it's important that we emphasize that in the event you get a question that is based on the graph. Now, calculate the total resistance of the circuit. So we want the total resistance of the circuit, or total external resistance. You must read that carefully, not like me. Because if you read total resistance, you will have to add the 0.5. But this one is saying total external. So we're only focusing on the external circuit. We have external circuit is all this that is outside. That's what this question is asking for. Now, definitely, you will first deal with the parallels there, which you can do when they are like that. You can use the parallel, the product over sum, which is 10 times 10 over 10 plus 10. You are able now to get your resistance there. And then when you get your answer, you add it to the 10 there, and then that is in parallel with that. Then you do again the parallel of these ones and the parallel of that one to get your answer. Now, in this case, you can start with the R12, and then which is your RL. This one, the resistor, this one is in series, but these two are in parallel, R1 and R2. So you must do product over sum, which is 10 over 10 over 10 plus 10. And if you use your calculator correctly, you will get your 15 ohms. And immediately when you get your 15 ohms, is for all of these added together is 15 ohms. So you are having 15 ohms that is in parallel with another 15 ohms. So definitely you can do another product over sum, which in this case it will definitely give you the 15 times 15 over 15 plus 15, which gives you 7.5. So you are able to, you can use that form option. I always emphasize to learners to use the formulas that are given in the data sheet. So when you're dealing with the parallel, this one is definitely given, and then you can use that option as well, so that you are able to get that these two is 5 ohms. When you get the 5 ohms, they are in series with this 10, and then it becomes 15. So you can use that. Then you have 10 plus 5, which is 15 ohms for the first part, and then because you're having a parallel, another parallel is 1 over 15 plus 1 over 15. You take the inverse of that, you get 7.5. So there are two options. They are both acceptable for you to write. And we're saying, what is the reading on the ammeter A1? Remember now, we want the reading on the ammeter. And then in this case, you're going to utilize now your EMF, because you were given everything. Your EMF here, you are having 12 volts. Your current is what we are looking for. The R external is 7.5, internal is 0.5. So it's just an adding and straightforward. And then you are able to get your 3 marks. Hence, you can see the number of marks. It is a routine calculation where you just substitute. Or you can use this option where you say EMF is the V total. So you can say R total equals to V total over I, which in this case would be 7.5 plus 0.5, which is R total. Our V total, which is EMF, is 12 over I, which in this case gives you current of 1.5, and then you are able to get your 5 marks. Calculate the power dissipated by resistor R3, and then you are able to go and look at R3, and then be able now to do your question, which is this one. We wanted you to calculate the power, and then in data collection, you are having P equals to VI, and then definitely you are having your power. You are looking for your power, and then you are able to do the substitution. You said I equals to 0.75. Remember, the total current that we have is 1.5, and because this is 15 ohms and this is 15 ohms, they are equal. It means that the 1.5 will be shared equally because they are equal resistance. So hence you divide the 1.5 by 2 to get 0.5 amperes. Just bear with me there, 1.5 amperes. And then you are able to say I squared R, which is 0.75 times what is the resistance, and then you calculate it by the resistance in this case, which is your 15 for R3, and then you're able to get your 8.44 watts, and that is your power that you have calculated. I hope that helps you. And then explain, in this case they're saying if the resistance of the light bulb remains constant, how will the brightness of the light bulb be affected? Choose. Switch S is now opened. This type of questions, you cannot lose those marks. Please, learners, switch S is now open. We are simply saying now we are opening here, we are removing this parallel part. Remember, immediately when you deal with the parallel circuit, immediately when you open the switch, it means that the total resistance will definitely increase. Remember, we said we have 15 here and this 15 that were in parallel, and we're able to calculate the total resistance, which is said is 15 times 15 over 15 plus 15. We are able to do that. But immediately when we open this switch, we now we now saying now we only have 10 plus 5. Remember these two, we said is 10 times 10 over 10 plus 10, which is 5. So we have 5 ohms plus 10 ohms, which is 15, which means the resistance increases. Oh, look at the signs now. I want you to look at it this way. The resistance increases. And you know what does it mean? When the resistance increases, the current will definitely decrease. And then if you look at our EMF, it remains constant, which is 12 volts. So if the current decreases, definitely it's going to affect the V internal. V internal equals to IR. And we're saying this I will decrease. When I decreases, V internally will definitely decrease. So V internal will decrease. V internal will decrease. R, the total resistance will increase. I will decrease. And V internal will decrease. EMF will remain the same. And if now you are having R increases, your V external will increase. I'm going to show you now as we conclude to say, okay, definitely we're going to have increases, we agree. And then as we move, we're saying the total resistance increases. We've agreed that immediately when you remove that, the resistance becomes 15 ohms, it increases, and the total current will decrease. We've said that V internal will decrease. We talked about that. V external will increase. Then the power output increases. Therefore, the brightness increases. So I hope you got that, because you are looking at V external being E minus V internal. Because now we said this one remains constant, is 12 volts. This one, V internal, will decrease because the current is decreasing. The internal resistance is 0.5. So definitely this one decreases. And when V internal decreases, definitely V external will increase. So you can see how you collect these marks. I hope this helps you as you come across this question. Remember, you are expecting a question on photoelectric effect and Doppler effect as well, which are the topics that we have done now in term 3. They are still fresh in your minds, and we are hoping that you will do well in terms of all those questions. I just want to emphasize the issue of definitions in terms of photoelectric effect, to say you will know how to define photoelectric effect. Please don't forget the threshold frequency, the work function. Be able to do those definitions. Definitely you will get at least one of them, and then be able to answer the questions. And then we are saying, as a final tip from me to yourself, to say time management. Don't spend too long on one question. Move on and return later if needed. Please, 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 please. There is a simple instruction that says start every question on a new page. It helps most of the time. Show all your steps. Even if you are unsure, write something. This is science, guys. As long as you wrote the formula, substitute on it, because we won't mark it if it's not substituted. Marks are often awarded for method of what have you followed. So please don't leave blank spaces, more especially on multiple choice questions. We're expecting A, B, C, D there from 1.1 to 1.10. All of them must be answered. And we're saying show all the steps. And we are saying stay calm and confident. Please, you have studied. Trust your preparation is enough that you have studied. Remember, FSAUD was saying formula, substitution, answer with correct SI unit and direction for vectors. Don't leave any multiple choice question or calculation question unanswered. Because when you say calculate, you know we need a formula. Go to the data sheet, get a formula, substitute on that formula, write the correct answer with the SI unit. Please, we don't want blank spaces. Answer all these questions. And then, as I conclude, physics is not about memorizing. It is about understanding how the world works. Trust your reasoning, and stay calm under pressure. So with that, I want to say just in time, tomorrow at 2:30 to 4 o'clock, paper 2 revision. And then I always want to say thank you with those words of Albert Einstein, who said, anyone who has never made a mistake has never tried anything new. Hence, we are saying don't leave any question unanswered till we meet again. Thank you very much.